this is not a graded quiz, but if it was, let's say we've got a continuous time signal that looks like this. My question is, find the minimum sampling frequency to prevent aliasing. Just take a minute and work that out. In general, we can write a continuous time system as using either this type of notation or that kind of notation. They're completely the same, except that here we're going to measure omega naught in radians per second, and here we're going to measure f naught in terms of hertz, which is the same thing as 1/seconds. So just by matching the numbers, we can say that here we have our capital omega, which is our continuous time frequency. Remember, we use capital of omega for continuous time, and we'll use lowercase omega for discrete time. And you won't see a hertz thing in continuous time, but this is continuous time, and this is discrete time. So omega naught is going to be 10, but we could just as well have written that as 2 pi f naught. So therefore, our continuous time frequency is equal to 10 over 2 pi, which is the same thing as 5/pi. And that, because it's a frequency, that's going to be in hertz, which is the same thing as 1/seconds. So in every 1 second, this thing is going to go through 5/pi oscillations. And then the second step is to say that the minimum sampling frequency is going to be 2 times the maximum frequency in the signal. So that's going to be 2 times 5/pi hertz. So that's going to be 10/pi, which is about 3.18 hertz. So that means that every second, you need at least 3.18 samples to prevent aliasing. If you have at least 3.18 samples, you can recreate this original signal and show that it has a continuous time of omega equals 10 radians per second, or equivalently 5/pi hertz. And if you sample at less than this, then you are going to incorrectly think that your original frequency is less than this.
So is the answer to the original question?
So the answer to the question is this.
10 over pi.